Hey everyone, today we're going to talk about different number groups, which I'm sure have talked about this stuff before. But I'm just going to give you a quick rundown of what those groups look like, and then on your homework, you'll have a couple different opportunities. We'll talk about that at the end. So, first group are called the natural numbers. The natural numbers. And those numbers are, it's kind of like another way to say the positive numbers. Positive, but it's like, I like to think of them as the counting numbers. Because if you were playing hide and seek, this is what you would do. You would start at 1, 2, 3, and it goes on forever. So the natural numbers just start at 1, 2, 3, and they will continue to go forever in that direction. Okay, those are the naturals. The next group's called the whole numbers. And the whole numbers are very similar to the natural numbers, but they start with 0. They include 0. So that's kind of a big distinction, which later in math you guys will learn there's a lot of things that you can have 0 on or you can't have 0 on. So the whole numbers kind of give us 0. And then they go all the rest of the naturals. So they go 0, 1, 2, 3, 4. And they go on forever. Right? And then what you're going to kind of see is that each time we add a little bit to each group. So the natural numbers were first, they had the positives, and then the whole numbers came along, they added zeros. Next we have the integers, and the integers have negatives. So this time they're going to go on forever in both directions. So this would start at, whatever, negative infinity. We'd have negative 3, there's stuff before this. Negative 3, negative 2, negative 1. They have 0, they have 1, they have 2, they have 3. And they go forever both sides. So all the negatives, all the positives, but notice that we still don't have any fractions or any decimals, anything like that. Okay? So the naturals, then the wholes, and the integers. All of those numbers are something, and this is the big group that we're going to talk about the most here at the beginning of the year. They are engulfed in the rational numbers. The rational numbers, a really good definition, one that you would probably want to have in your notes, is any number you can write as a fraction. Any number you can write as a fraction. So you're probably thinking there saying, Mr. Rody, what kind of numbers can I write as a fraction, right? Well, the natural numbers, you can write all of those as a fraction. You would just put it over 1. So like 5 over 1, 18 over 1. Same with the whole numbers. We can do the same thing with 0. 0 over 1 is a fraction, right? The integers are all rational. You can do that with the negatives. Negative 7 over 1, negative 6 over 1, right? All those other things. And then there's some other numbers here. So obviously we have fractions here, because a fraction's a fraction, right? But the tricky part is some decimals. And this is where it gets confusing. There are only some decimals that are rational. You can kind of split them up into two groups. So they're the terminating decimals. These are all rational. That's what these are falling under, okay? Terminating decimals. And there's repeating decimals. Those are the two types of decimals that you're going to find that are rational numbers. You can make them both fractions, which we're going to talk about, I think, tomorrow. sometime this week for sure. So terminating decimals are decimals that end. Any decimal that you see the ending to is rational. So like 0.25, 0.7111, right? Anything that you see it ends, it doesn't keep going forever and ever and ever, that is a terminating decimal, which means it's a rational number. We can write it as a fraction. Repeating decimals are also rational numbers. So these, I would say, are decimals that show the same pattern forever. Decimals that show the same pattern forever. And when I say show the same pattern, I'm going to show you an example of like a tricky one that you're going to be like, oh, that's a pattern, but it's not rational. I'm talking about numbers that just repeat the same sequence. So like 0.33333333333 forever. That's rational. You can write that as a fraction. Maybe you're used to seeing 0.28 and then it has a line over it. You guys, have you seen that before? That means it keeps going forever and ever and ever. That's a rational number. 0.282828282828, right? And it could have as many digits as it wants in that sequence that repeats, but the key is that it's the same set of numbers over and over and over forever. These are the only two types of decimals that are going to fall into this rational numbers here, okay? So we have all of these numbers that are rational, and then these two specific types of decimals. So I was going to say, like, you make sure you have this down, but obviously you can pause your video at any time, right? Yeah, so I'm going to erase this. So then you're probably thinking, Mr. Rody, okay, I get the decimals that are rational, so what happens if you can't write something as a fraction? Those numbers are called the irrational numbers. They are irrational. And those numbers are numbers you can't write as a fraction. So what would those numbers look like? Well, they're going to be decimals that go on forever, but do not repeat. Decimals that go on forever, but they don't repeat. There's not a pattern there that just has the same sequence over and over and over. So, something like 0.216615703228 blah 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 blah, right? It has to go on forever, so we need this. However, as you see here, there's no, yes, the 6 shows up more than once, but that's not a pattern, right? That's not a set number, you know, the same set over and over and over. This is kind of random digits. And that's what irrational numbers are going to look like. You probably are thinking the most famous irrational number, I would assume, is the number pi, right? Which is approximately 3.141592653, blah, 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 blah. It keeps going on forever. That's why it's irrational. We can't write that as a fraction. So some tricky ones that you will see, anything with the number pi, it doesn't matter if we add, subtract, multiply, divide, those things are not going to be rational numbers. So you may see something that says like pi over 3 and think, yeah, that's a fraction, Mr. Odie. It's pi over 3. It's not really though, right? Because this is an irrational number. So even if we put it over 3, it's not technically, even though it looks like a fraction, that's not a fraction. Because pi is irrational and you can't have an irrational number in a fraction. One that I have seen often on tests is something like 0.12, 112, 1112, 11112. And people will say, well, that's a pattern, and it keeps going, right? But it's not the same set digits over and over and over again. So yes, it's a pattern. Don't get confused by that. But this is an irrational number because it's not the same set numbers over and over and over and over. We are going to talk throughout Unit 1 on a lot of things that have to do with rational numbers and irrational numbers. One of the biggest groups of irrational numbers I haven't even talked about are square roots. And we're going to talk about that later this week, but like the square root of 2 is irrational. And we're going to talk about why and how we know that and what those square roots are going to look like later this week. You know, a little teaser for you, so you can come back for more. That's what they do in the movie business. That's obviously the business I'm in now because I'm making movies where I'm too tall for the screen. Great. So we have rationals. We can write them as fractions. We have irrationals. We cannot. They don't work so well. However, all of those numbers are in a group that's called the real number group, the real number system. So all of those are real numbers. And real numbers are really just the combination of the rationals and irrationals. So, a really good way to think about that is every number that you guys know about is a real number right now. When you guys get to high school, you're going to talk about the complex number system, which are not real numbers. They're actually imaginary numbers. They're like the bing bong of numbers. But for now, everything that you guys know is a real number. So when I give you a paper that says, tell me what number groups these are in, all of them are going to be real numbers. Because they're either going to be, you can write them as a fraction, or you can't write them as a fraction. Those are really your only choices right now. So, here's what I want you guys to do for homework. On a Google Doc that you're going to submit to me, try these. I would like to know, we'll do 6. So I'm going to give you -7. I'm going to give you, 2 comes after 1. I'm going to give you 0.38579. I'm going to give you 8, which is one of my personal favorite numbers. We'll do 0.1138713996. We will do -2/3. And the last one we're going to do, we'll say a 0. Okay? I want you to take those 6 and tell me each group that it belongs in. So if I said, for example, the number 11. 11 is a natural number, so I would type natural. It is a whole number. It is an integer. It is rational. And it's a real number. So it would be 5 different groups. I need to put all of those groups. However, some of them might only be in 2 of the groups. So that's it's either going to be from between 2 and 5 answers for each one of these. So try those out. Submit them to me on Google Classroom, and I'll kind of shoot you back something to tell you how you did. All right? Cool. We'll see you guys tomorrow.